A beetle clings to a leaf above a mangrove stream. Below it, a fish rises until the tip of its mouth touches the surface. The insect is nearly invisible among the branches. The fish cannot reach it, so it fires. A narrow jet of water crosses the air, striking the beetle, and forcefully tears it away from the leaf. Before the insect reaches the surface, the fish has already turned. This is the highly specialized archerfish of the mangroves. It must aim through a surface that bends light. It's a calculated shot, one requiring precise optical correction.
Shape water into a powerful projectile and predict a falling target
before another hungry competitor can steal the hard-earned meal. How can a fish shoot prey down from a tree?
Archerfish live in tropical rivers, mangroves, and estuaries across Asia.
They are also widely distributed across the vast northern territories. Much of their prey rests on leaves beyond ordinary reach. The archerfish solves that problem by turning its mouth into a cannon.
It presses its tongue against a groove in its mouth. Then it rapidly closes its gill covers, forcing water out.
But producing a stream is only the beginning.
The fish is looking from water into air. At that boundary, the light bends and distorts the view.
An insect appears higher and closer than it really is.
Wind, surface movement, and gravity add even more errors.
One mistake leaves the insect safe on the branch.
Researchers recorded trained archerfish with high-speed cameras. They discovered that the stream leaves at variable speeds. Water released near the end travels faster than the front.
The faster rear portion catches up, concentrating the stream.
Much of the water reaches the target together.
The fish changes the timing of this acceleration,
allowing the strongest part of the jet to form nearby.
Adults can also adjust the volume of water. A larger insect demands a longer, stronger shot,
while a small nearby target requires far less. The mouth becomes a flexible launcher, not a fixed nozzle.
The archerfish is controlling the jet throughout the shot.
Scientists also tested how the fish responds to wind.
When airflow pushed the jet sideways, the first shots missed.
After repeated attempts, the fish gradually corrected its aim.
When the airflow was removed, it briefly aimed too far. It aimed too far in the opposite direction.
That after effect showed it had learned a new adjustment. Yet even a perfect shot creates another problem. The moment the insect falls, rivals race toward it. The archerfish therefore uses two deeply linked calculations. First, it predicts where to aim above the surface. Then it predicts where the falling prey will land. Once the insect begins moving, the fish analyzes it. Its nervous system estimates the future landing point. Within a fraction of a second, it bends. It bends into a C shape and launches forward.
This maneuver turns the body toward the impact point
and produces enough speed to arrive with the prey. The shooter does not need to wait for impact. In fact, waiting would be too slow. Other fish can detect the impact and steal it. The archerfish gains its advantage by moving early.
Even a bystander can watch and calculate the landing.
The pursuit combines optics, fluid dynamics, and prediction. This sophisticated system is impressive, but not perfect.
Young archerfish are generally far less accurate initially. Leaves and wind can easily block the shot.
A firmly attached insect may survive, while falling prey can bounce from vegetation. The archerfish also depends heavily on vision. In very low light, it may lose its rapid, predictive turn and arrive too late. And shooting does not guarantee ownership. A faster competitor can still steal the meal. The water jet creates an opportunity. It does not end the competition. The beetle loses its grip. Below, the archerfish bends into a sea before the first ripple appears. The insect falls through the air. The fish accelerates toward an empty point on the surface. Then prey and predator arrive together. The archerfish corrected for a distorted image, shaped the jet, and predicted where a newly falling target would land. It hunts in two worlds at once, and its weapon is nothing more than water, aimed with extraordinary precision.